Hi students, greetings. Welcome to this course, Analytical Methods and Instrumentation. In this course, I'm going to teach you about the basic instruments and their principles, working principles used for biological research. And also we are going to cover with the other applications of these instruments than the components of instrument. Okay. And then the objectives of this course given by Analytical is there are two objectives. The one is we are going to enable you with the knowledge of light spectrum, absorption, fluorescence, NMR, and mass spectrophotometer. Like that, the second objective is to give a knowledge about different types of chromatographics, especially which are used in protein or enzyme separations in biotechnology. So, the outcome is after completion of this course, you should are able to have the better understanding about all types of spectrophotometers and all types of chromatographic techniques. So then only you can choose that appropriate technique for the respective samples which you are going to analyze, right? The book suggested for you is Instrumentation, Instrumental Methods of Analysis by Skoog, Holler and Crouch. Actually, I am using the latest edition of the book called Principles of Instrumental Analysis. You also get the copy of ebook from the net sources. And coming to the syllabus introduction, as usual, this course also have the 5 units. Unit 1 is about introduction to the spectrophotometry, which means method about using the spectrum of the light, right? So this unit deals with the properties of electromagnetic radiation and the instrumental composition of instrumental components of the spectrophotometer, right? At last, how to get the signal or enriched signal without any noise. And this is about the first unit. And the second unit is very full of spectrophotometers, variety of spectrophotometry, like such as absorption spectrophotometer. Then next one is emission spectrophotometers. Phosphorescence and fluorescence are emission. Both the absorption and emission spectrophotometers principle is same, because when the sample get absorb the light, the sample electron in the samples are get excited and go to the excited state level from the ground state, right? In this context, we are going to analyze the absorption. Some of the molecules emit the light when returned to the ground state. So that is phosphorescence and fluorescence. Fluorescence is immediate emission and phosphorescence is little bit later than the fluorescence, so which is called as cold light also. And the next one is about IR. So in the both previous cases we are using the high energy wavelength radiation. It can excite the molecule. Coming to the IR, it is comparatively lower energy, so it can produce only the vibration of the molecules. By this way we can study the bond structure, rotation of that bonds and the molecules which is attached to that component, or we can easily study by using the vibration. Different types of vibrations, there are 4 or 5 types of vibrations are there generally to study. And the last one is scattering techniques, which is Raman scattering, which is used by Raman spectroscopy. Usually the Rayleigh scattering and Raman scattering are used as a principle to find the molecule which are present in the sample. The Raman spectroscopy is one of the classical method, but still it is using to analyze the sample as a supporting measure. It is very simple also than other methods, because it is used to water as a solvent. So the unit 3, and in the unit 2 the important concept is Bayer's law, which relate the concentration of the sample to the absorptions of the light intensity. Right, we will see during that unit 2. And unit 3 about magnetic resonance spectroscopy and mass spectrometry. Right, in this magnetic resonance spectroscopy is about NMR, this nuclear magnetic spectroscopy, actually nuclear magnetic resonance. In this we are going to put a sample in between the two magnetic field, and we are giving the electrical charge also. What happens, we are in this, the molecule gets spin. So spinning is the main concept of this, especially in nuclear spin. Protons get how it gets the direction of, and how it gets orientation in that magnetic field, right? By this way we can easily find out, with the help of mass spectrophotometer, what the compound present in that. And the fourth unit is full of separation techniques. We already knew that one of the objective is to enable you students with the chromatographic techniques, because we are using this widely for molecule separation, right? There are so many separation techniques in this chromatographic based on the charges, affinity, and molecular size, right? So you should give more importance to this unit than others, I think, because it is practically important. And the last one is about electroanalysis and the surface microscopy. And the previous 4 units we have seen about the spectrophotometers, such as absorption, emission, and scattering, vibrational, all those things, and separation also we have seen that. In this last unit mainly deals with the electrical property of the sample and solution, right? So ionic properties will be measured. It is used to find the sample, what kind of sample it is, like that. Mostly here we are using potential of the sample or conductance of the sample, right? Ability to conduct the current is measured. At the end of the unit we are using the AFM and STM, which is mostly used to find the surface structure of the sample, right, at the nano level. So this is about your syllabus of instrumental methods of analysis. At summary, the first unit is full of optical instruments and how to use the electromagnetic radiation about to analyze the sample. And the second unit is full of variety of instruments, spectrophotometric instruments, such as absorption, emission, and scattering, and vibrational, right? And in vibrational we can use FTIR, which is Fourier transform infrared analysis. We can use the almost all the 3 regions, near IR, far IR, and mid IR. That depends upon the molecules, right? So the third unit is full of identification of peaks in the NMR, nuclear magnetic resonance peaks, and to find out the molecules, and like how many carbons are there in that molecule and which position it is, you can easily find out. In that, the separation techniques is full of chromatographic, such as ionic exchange, affinity chromatography, size exclusion chromatography, all those things. In the fifth unit, it should be about the electrical conductance properties of the sample in a solution. Then the surface spectroscopy to find out the molecular surface of the given sample. So I think it is very easy to you to follow this course, and all the best for you.